Sorry, jerky playback ruining the vibe. If you actually run the real demo, it's actually smoother than this playback of a video. And it's smaller. So, so that's what's possible.
Yeah, it's a gargantuan difference in size. I don't know what happened with that playback. We had tested it before. So go check it out. Go to puit.net. Type in Parsec. There's 2 productions. One's 4K. You'll know which one. So with our talk here, we're going to talk about evolving reduction. And the way that we're going to do this is that we've taken a source application from Nehe, from nehe.gamedev.net, which Jeff has up there a number of OpenGL tutorials. I think he's up to like 35 now of various subjects. And we've taken a very simple one, which has a rotating cube and a rotating pyramid, a 4-sided pyramid, that as a sample. And we're going to show you a variety of techniques to bring that down as far as we know we can go. We actually had done the presentation, then I was in the airport and managed to start to fuddle with some other ideas, and we've since being here have made some other optimizations that STech will talk to as well. So if you take that and you download it and you stick it in a compiler, the output is 11K, basically. Now, you're sort of sitting there saying, okay, wait a minute, Dave. We just saw a production with this huge sphere, this beautiful scene with particle effects, with what probably has pixel shaders. I don't know the internals of it, so I can only guess. And yet, to display a cube and a pyramid, flat shaded with some coloring, it already takes 11K out of the box. How the heck is this possible? So we're going to show 2 overall approaches. One is to talk about some OS-based techniques, which are really more about how to represent your program and your code environment. And then we're going to look at algorithmic. So one is inside the box, right? That's more what are we doing, how are we representing this. The other one's outside the box type of approaches. And all the presentation files, as I mentioned earlier, will be made on in 4K. So what are we trying to do? Well, you're trying to make a very small program, really. An executable image. And before you can really intelligently think about that, you're going to have to find out what an executable image actually is. Now, I know that there's the ELF format for the Linux gurus in the group. I'm not a Linux guru. However, some of the things that I will show apply to Linux, so I'm going to be talking mostly about the Win32 format. The Win32 format in Windows executables is the PE format, or portable executable format. And it's similar to the COFF format or the ELF format. And you can see that you have a header, stubs, another header, a section table, and then a whole bunch of sections. Now, the header, the first one is the DOS header, which basically says, congratulations, you have tried running this program on this DOS program or a Windows program in DOS. And so it basically says, hey, you can't run this program. So it's a legacy thing that's in all executables by default to say, sorry, you don't have Windows. Too bad for you. And the PE header holds the standard structures for the PE loader, and then you've got the section table. And I want to stop you from thinking that, oh, okay, I've got code, I've got data, and these are different sections, because they're not. The only thing that really puts things into various sections is its attributes. Can it be read? Can it be written to? It's more of a question of what are the rights of storing that data that decides whether it's in a section or not, as well as your standard compiler options. So the sections hold a block of data. These can be anything, right? API functions, they can be imports, values, variables, and so forth. So they have a chunk of data, and there's nothing that prevents them from being in the same section. And one of the first things that you may do as someone who's interested in 4K intro development is actually merge those two sections together. The compiler and linker determines how many sections there are, and there's some additional information that you can follow up on. The real goal that I want you to understand is that there's a whole bunch of headers that are in every single executable. And some of these headers have no value to a 4 kilobyte production. I'm sorry, but at some point you decide, well, you know what, we can live without error checking. Oh, and that object I allocate, well, guess what? I'm not going to deallocate it. I'm just going to have to rely on the operating system to remove my object in memory. You start doing these things not because it's improper technique to do it. Of course, it's proper technique. You should clean up the things that you do. But when you're making a 4K, you're more interested in having that next scene having buildings in it than saying, oh, guess what? I deallocated everything I allocated and didn't rely on the OS. Right? So the first approach that a lot of 4 kilobyte intro coders use is they use an out-of-the-box compression tool. And that basically takes your program and it compresses it. And to use another example, let's say that we have a living creature. And the living creature weighs X on a scale. So what this does basically is it decides to consume the living creature and store it in a lighter way. So it's like it replaces its blood with helium or something, and it basically just stores it in a compressed way. Then when you say, okay, I want my living creature back, it actually pulls it out, extracts it, runs it, just like it was the original creature. And I know that's kind of and so on, but essentially what you have is you have another EXE or image, executable image, that looks just like the original image when it runs, but it extracts itself to memory or to disk and runs it. So the program runs it, and the hope is that the compression algorithm and the code is smaller when stored in that form. So we decided to take the sample, which remember it's at 11K right now, and to use UPX on it, which you can download. It's a SourceForge application. It's a very popular application. It's very well tested. There's versions for almost every OS out there on the planet. And we ran it through this. And we end up with a just over 6K production, which is a nice reduction. It gives us roughly 41%, which is still a far cry when you say, hey, well, we need to get that magical 4096, right? Now, there's really one major disadvantage with this. Do you remember going back here when I said this stub and some of these things are really useless, right? I don't think a 4K intro developer is going to mind if their executable, when run in a DOS box, doesn't work, right? So we want to hack it slash and burn that. So this approach creates another Windows executable with the same DOS stub, or to say, hey, guess what? I can't run this. So we really need to find a way of representing the code such that we don't have that problem anymore. So there's actually another executable image format that's supported by the Microsoft Windows platform, and that's called .com. I don't mean .com in sort of the industry sense or the internet sense. This predates that. It's essentially a very small executable format that has no data, that has a maximum size of 64 kilobytes. And that's supported by the original DOS platform. And it can be loaded at basically hex address and so forth. So somebody said, okay, well, guess what? What I'm going to do, instead of writing a Windows executable, I'm going to write a DOS executable, and I'm going to tack on the Windows executable. And this DOS executable, what it's going to do is it's going to write to disk the Windows executable. It's going to run it, and then if it's being nice, it's going to delete it once it's finished running. So it essentially drops this executable to disk. Now you're saying, okay, well, wait a minute. You took this program. It's got, okay, I understand it's a Windows executable. It has this header, and then you're writing this other program that spits it to disk. This doesn't make sense to me. Well, the reason why you do that is because then you can compress the whole thing. And when you compress the whole thing, you've gone back and you've compressed, again with that chart, that header right there. So you can actually shrink down those strings in that code, and you end up saving on that header. It's not really elegant. It means that you have this little DOS box, that pops up when it's run, but it does save a fair bit in the approach. There's several file droppers that you can use. For our testing, we used GEMS dropper, and we used APAC in order to compress it. So GEMS dropper, what it does is it took the Windows executable, it tacks on the DOS program as a .com file that writes it out, runs it, deletes it, and then we used APAC to compress that .com file into the smallest version possible. So you can see at this point, we've gone down to about 5K. So we're not quite there, but we're getting much closer. Now, one of the things that you'll have to remember, though, is it's merging these two things in uncompressed form as a program that's a run stub and the executable image afterwards. So, pop quiz, anyone who's really on the ball here, what does that mean about the largest uncompressible size of your production? What I mean by that is, what is the largest production that you can tack on to a stub and have it run as a COM file? Exactly. So you've got your overhead for whatever your stub is, right? And then you've got just, let's say it's, 100 bytes or so. Then you've got 64K less, right? That basically means that the largest production you could support with this and then compress is 64K because it shows up as a COM file. Very good. So writing to disk can be a problem. Some demo competitions actually don't allow you to do it. I remember I checked with, here's something that goes back. I checked with Assembly before entering in their competition to see if it was a permissible technique. We didn't use it because they said, no, don't write to disk at all. So we used UPX, and we had a very limited size that we could work with. And then that year, 5 out of the 10 productions all used file dropping. So it's a bit frustrating, and the rules have since been changed to accommodate it. Some compile rules say that you need to put it in the system's temporary directory, which means that you then need to have this overhead code which figures out where to write it to. And again, I mentioned the 64K limit as a bit of a test. So you can see that that may impact the ultimate size your production can be. So there's a very smart individual, a Hungarian individual by the name of, that goes by the demo scene by the name of M. And he realized two things. One is he realized that Windows has cabinet files, which are equivalent to, in Linux, you might think of them as gzip tars, or zip files. You can think of them as zip files, right? So there's this native inside the operating system file format that's supported with command line tools inside the operating system that you can access. Now, the real advantage of using that is that at that point, you've got an algorithm you can access without having to store the algorithm. You only need to store, hey, I need to uncompress this, and to call or make use of the algorithm. So it's built in. It uses LZX compression, which is also typically better than UPX or APAC. And the end result is there were two sort of phases to it. One was having a batch file that called the command line to extract the production from the cabinet file and then run it. So the size of your production then actually gets split into two different files. And your production size is the sum of that batch file, which is just a script file that says, I want you to extract this now, I want you to run this program, I want you to delete the file now. Or how do we get it so that it's a single batch file? And that's something that's also been done. So there's sort of two phases to it. One was to say, let's include a batch file that runs it, drops the cab file, does everything that's there, runs the executable, or later on there was a second phase that said, okay, let's find a way of combining these two together. So you can see I've got a sample script on the top right. I apologize for those that may be in the back having a little bit of trouble with it. But it basically says extract x.cab or extract 32x